Okay, so the video today is about all the different ways that you can find the points of intersection, or the point of intersection between two straight lines. So a quick run back over it. First of all, the way that the lines are presented to us, we'll just take one of them, x plus y equals to 6. This is what we say is in the form ax plus by equals to c. We could, of course, move that 6 over to the left, and we could say x plus y minus 6 is equal to 0. And it's still called ABC form, so it's in the form ax plus by plus c equals to 0. The main thing is that it's in the ABC form. Probably what's worth noting as well then is if you take x plus y equals to 6, you can rearrange that into the mx plus c form. So you can say y is equal to minus x plus 6. So this is in the form y is equal to mx plus c. And you'll recall that m is the slope and c is the y-intercept. Now what that means is that we can graph that. But before I do, I'm just going to take the other equation down. It's 2x plus y equals to 8. And I'm also going to put that into the form y is equal to mx plus c. So minus 2x plus 8. So my two equations, which were originally x plus y is equal to 6 and 2x plus y is equal to 8, have now been converted or moved or rearranged so that the first one now has become y is equal to minus x plus 6, and the second one has now become y is equal to minus 2x plus 8. Now that they're in that form, there are different things that you can do. Remember, our goal is still to try and find the point of intersection. So one option may be to graph them. So that's what I'm going to do now. So I'm going to take the first equation, y is equal to minus x plus 6. I'm going to say that the slope is equal to minus 1 over 1, and that the y-intercept is equal to 6. I'm going to take the second equation, which is y is equal to minus 2x plus 8. So I know that the slope is equal to minus 2, which is the same as minus 2 over plus 1. And I know that this here is my y-intercept. So that's going to equal to 8. Second. Now that I've got these couple of pieces of information, I can start to sketch things out and I can start to draw them. So I'm going to draw myself a y-axis. And an x-axis. I can start to mark these out. So I'll say 1, 2, 3, 4, 5, 6, 7, 8. Taking the first equation, so just to remind you, it's up there at the top, the two pieces of information. This is the first one that I'm going to use. So its y-intercept is 6. And recall,
with all the students now from 1A down, please go to the library now. Thank you.
And recall, please, that the slope is minus 1 over 1. We'll deal with that in more detail in just a second. So that means that the starting point for my first equation is at minus 6. If the slope is minus 1 over 1, that's vertical over horizontal. So that means I'm going to travel down 1 unit and across 1 unit. So I'm going to travel down 1 unit and across 1 unit to here. Now that I've got my start point and my finish point, line goes through them. And this line is the line y is equal to minus x plus 6. I now need to repeat that process again for the second line that I'm being asked to work with, which is y is equal to minus 2x plus 8. So minus 2x plus 8, the y-intercept is 8, so that my beginning point here is 8. But its slope is minus 2 over 1, vertical over horizontal. So vertically I will travel down 2 units, and then I will horizontally travel 1 unit. So I'm starting at 8, I will travel down 2 units, that will bring me to 6, and across 1 unit, that will bring me to here. Now that I've got my start point and my finish point, ruler goes down, run your line straight through them. And you can see that when you've got the two lines drawn, you can read off their point of intersection. And it looks like it's about 4-2-ish, using a marker. So we'll just say 4-2 and we'll see what we end up with. Sorry, 2-4. X value first, then the Y value. So 2-4. Now, of course, graph drawing is one way that you can do it, but as we've seen before, it's not as accurate maybe as other ways. So we can do this algebraically. So we'll just put this in the back burner and we'll solve our question algebraically using two different methods, and then we can come back and make a comparison against our point of 2-4. Okay, so the original question was written as x plus y is equal to 6 and 2x plus y is equal to 8. There we go. So the procedure one of the procedures that you would have seen is there is a 1 here that we don't tend to show, and we just do a little bit of crisscrossing with our multiplication. So we'll multiply the bottom row by 1 because 1 is the number in front of the x here, and we'll multiply the top row by 2. We'll multiply the top row by 2 because that's the number in front of the second equation. So this 2 has to multiply into everything. So 2 by 1, taking that top line, 2 by 1 will be 2x plus 2y is equal to 12. Multiplying the bottom row by 1, you'll end up with 2x plus 1y, or y, is equal to 8. So there's no change. Once you've got that done, you change all the signs on the bottom. So this will go to a minus, this will go to a minus, and this will go to a minus. Adding the rows, the columns, 2x minus 2x, they're gone. That will give you 0. 2y minus y, that gives you y, equals to 12 take 8 is 4. Once you've got your y value, you take, and it doesn't matter whether you put it back into the original equation number 1 or the second equation, either equation will still give you the same answer, but you're going to have to take this value of 4 and put it back in to get your value of x. So just out of habit, I always take the first one. So I've got x plus y is equal to 6. So that means that x plus 4 is equal to 6. That means x is equal to 6 take 4. That means that x is equal to 2. You take a look at the x value and the y value there. So the xy, 2, 4. Just remind you, that fits in with what we would have done when we graphed. There you go, 2, 4. So when you're asked to solve for the point of intersection, you can graph it out, which is okay, but it's not overly accurate. Or you can use a simultaneous equation, which is the method that I've just shown you here. However, sometimes equations, if you recall again, this is in the ax plus by equals to c form. Sometimes you're given equations that from the beginning of a question that aren't in this particular form. So again, let's just take our x plus y equals to 6, right? And our 2x plus y is equal to 8. And let's just say, for argument's sake, that they had been given to us not in this format, not in the ABC form, but in the y is equal to minus x plus 6 form. So it's the y is equal to mx plus c form. So what would your options be if, for argument's sake, this isn't what you had been given, and let's just say this is what you were asked to work with from the beginning? Well, of course, you've got two options, one of which is actually to convert from the mx plus c, so bring it from this version back, so just undo the process that you've just seen. Or, and I prefer that, well, this is just an alternative. When you talk about the point of intersection, you're talking about where the two curves meet. And if you take that a step further, what you're talking about is where are the x values equal, and or where the y values equal. So in other words, point of intersection, yes, it's where the lines meet, but you're really saying where are the x and y values the same. That's what you're really asking yourself. So in other words, what you can say is, well, if the y values are equal, can I not just put y equal to y? And if y is equal to y, well, if y is equal to minus x plus 6 from the first equation, can I not just put this in here? And if y is equal to minus 2x plus 8 from the second equation, can I not just put it in here? What you see is you've got a little linear equation, one variable, the only thing you don't know is x. I'm going to bring the x's to the left hand side, I'll bring the numbers to the right hand side. So I'll have minus x plus 2x is equal to 8 minus 6. You'll end up with x is equal to 2. Of course, now that you have an x value, you need to take that x value and pop it back into one of the originals. Doesn't matter which equation you put it into. I'll take the first because that's what I usually do. So the first equation was x is equal to y is equal to minus x plus 6. So my x value here is 2. I'm going to pop it in here. So y is equal to minus 2 plus 6. Minus 2 plus 6 gives you y equals to 4. If you take a look and combine, the x value is 2, the y value is 4. So that answer of 2, 4 sits perfectly with our other method, which is our cancellation method, and it also sits perfectly with our graph drawing method, which we saw at the very beginning. So you have three different ways to solve equations. I suppose just one last comment, because an ability to solve simultaneous equations like this relies on you being able to move between the two different forms of an equation. So just a quick reminder again, you've got the ax plus by equals to c version, which in our case was 2x plus y equals to 8. And you've got the y is equal to mx plus c version. To convert from the ABC version into the mx plus c version, just get y on its own. So in other words, the 2x is going to move. And obviously it doesn't just move, you take 2x from both sides. So y is equal to minus 2x plus 8. Because just in case some of you are unclear here, I'm taking away 2x there. So what I do to one side, I must do to the other. And then I just choose to write this in a straight line. So that's converting from the ABC version into the mx plus c. Of course, if for argument's sake, a question was given to you in the mx plus c version, so let's just say the question was written as y is equal to minus 2x plus 8. It was written for you like that. well then all you would be doing is bringing everything over, all the variables I suppose, over to one side. How do you do something like that? You add 2x to both sides. So the two x's, they cancel away for you there, and I just choose to write this in a line. 2x plus y is equal to 8. So you have to be able to move between the two versions. Probably another comment that I should make is that sometimes you can be given an equation. So you could be asked, now this is more related to graph drawing. So for example, 2x plus y equals to 8. You could be asked to graph this in the domain, and that domain could be anything, minus 4 to 3. If you get given a question like this, again in terms of graphing it, you know that you're going to set up a table. But very often, and I suppose a general rule of thumb is, if what you're given is in the ABC version, it is probably more convenient to convert that into y is equal to minus 2x plus 8 into the mx plus c version and then set up your table. Because you'll have your x values, your y values, and minus 2x plus 8 can go in on the top of your table. One final point as well, because it's linear, you don't necessarily, you've got minus 4, minus 3, minus 2, minus 1, etc. You only need to work with two of those values. Generally speaking, use the first value given in the domain, which is minus 4, and the last value given in the domain, which in this case is 3. And it would just be an alternative way to graph the linear. Okay.